And in this new kind of matrix, instead of the equal sign, we draw a straight line. That's kind of like where the equal sign is. And we have the coefficients on one side and the answers on the other side. Now, this is probably one of the easiest systems of equations you'll ever solve. I'm like, I wonder what y is. Because they already told us what y is. It'd be super easy to plug that back in and get x to be minus 1. Okay? So this is an augmented matrix. And this one's easy to solve because we have a 0 here in the bottom left-hand corner. As soon as you have a 0 in that bottom left-hand corner, it's really easy to figure out what y is, even if those numbers are different. That's going to be sort of the key to Gaussian elimination. Okay? This type of matrix with the zeros in the bottom left-hand corner is called row echelon form. Remember earlier I said, hey, you have this button on your calculator that's ref? Yeah, you remember. That's row echelon form. And you can have row echelon form for a 3 by 3, like a 3 by 3 augmented matrix, 1, 2, 3, 8, 0, 5, 2, 9, 0, 0, 1, 6. Now, there's a whole bunch in the bottom corner that all have to be zeros. But if you had this, you would know that z is equal to 6. And then you could go up one equation and say, I know that 5y plus 2z, which happen to be 6, is equal to 9, and then you could figure out what y is. And then you could go to the last one, and once you figure out what y is, you could say, I know that 1x plus 2, whatever y is, plus 3 times 6, because z is 6, has to equal 8, and you could solve them all. So if we have zeros in the bottom corner, we could rewrite the equations and we'd be really close to solving. Now, we can transform any matrix into row echelon form with a method kind of like elimination, but much more, it's cleaner than what we did with our equations before. Because in our equations before, you could always get rid of a variable with the elimination, get rid of one of the variables, and then it would be gone, and you would sort of be getting a 0 there. But we're going to learn to do that with matrices, which is cleaner because you don't always have to write the x, y's, and z's. And it'll be systematic, so it sort of flows nicer. And it's a little bit nicer than our regular solving systems of equations from before. But because it's more abstract, your chances of mental math mistakes probably increase a little bit. So, what are we going to do? We're going to create the augmented matrix, coefficients matrix A, answer matrix B with a line in between. We're going to use what are called elementary row reducing operations. Almost spells the word error, which sounds like it's the last thing you would want to use when doing math. But to get zeros in the bottom left-hand corner, what are elementary row operations? These are things you're allowed to do in matrices at any time you like. You can switch any two rows. Right? If you had two equations with two unknowns, and someone's like, oh, can you solve this one? And they just switch them. You'd be like, those are the same two equations. So switching them doesn't change anything that it's equal to. You can multiply any row by any number. Like if you doubled an equation, if you multiplied one side of the equation by 2 and the other side of the equation by 2, it's still the same equation. Just the coefficients and the answer are going to change. And then you can add the multiple of one row to another row. Because that's like the elimination method. When you had two equations, you could add those two equations together, get something new underneath. That's totally allowed as well. Then once you get the zeros in that bottom left-hand corner. Now it's just a matter of working backwards to find all of our answers. I feel like doing math today. Apparently this doesn't want me to erase very much. Did it erase it all successfully, beautifully? Nothing there. So what we're going to do is we're going to set up our augmented matrix. Coefficients are 1, negative 2, and our answer is 10. Second one, 1 and 4, and our answer is 16. Our goal is to change this to a 0. So this is how I like to show my row operations. I draw an arrow, say I'm going to change something, and then on the arrow, I say what I'm going to do. I'm going to change row 2, so I write row 2. Maybe I'll put dots there, or maybe an equal sign. I'm going to make row 2 now equal to, and I can use any of my row operations, which is switch, multiply something, exchange something, or add or subtract a multiple of something else. Do you see that if you took 1 minus 1, if I took row 1 and subtracted row 2, that would make a 0 there? So what happens is now, redraw my row augmented matrix. In my instructions, I'm saying I'm changing row 2. So I leave row 1 exactly the way it was. 1, negative 2, and 10. And I said row 2 is now going to equal row 1 minus row 2. So if I took row 1, 1 minus 1, that makes 0. Negative 2 minus 4, that makes negative 6. 10 minus 16, that makes negative 6. This now tells me equation 2 is negative 6y equals negative 6. I think I'm onto something here. What do you think y is going to be? Oh, amazing. 1. And now that I know y is 1, I can go to equation 1, which says that x minus 2y, which I can plug in a 1, has to equal 10. X has to be 12. And it's really kind of clean as far as your work is going. Didn't have to rewrite the equations and, subtract on top of them and stuff like that. Double check, does it work? 12 minus 1 is 10. Good. And 12 plus 4 is 16. Good. Nice. Beautiful. So this is Gaussian elimination. Trying to get that bottom number into a 1. And you're allowed to do anything like this, adding and subtracting. You could put numbers in front of things. So I could take, if I wanted to, I could make row 2 15 row 1s minus 72 row 2s, if I wanted to. Okay? Like it. Here we go. I set up my augmented matrix. 2, negative 3, negative 2, 4, 1, 24. My goal is to get this to be a 0. So when I draw my arrow here, I'm going to change row 2, because that's what I want to have to 0. Any ideas how to get that to be a 0? Could flip them. I could make them either one. Yeah, I could flip them to begin with. But there's a way to make it 0. What would you do?
You could do 2 times row 1 minus row 2.
You could do 2 times row 1 minus row 2, or you could do row 2 minus 2 row 1s. Whichever, it doesn't matter. Whatever helps you with your mental math. So say whichever one you said again for me.
2 row 1 minus row 2.
2 row 1s minus row 2. And since we're changing row 2, we can just keep row 1 the same. So if you doubled this one and minus, perfect. We've got a 0 there, right? Negative 6 minus 1. Does that give you minus 7? Okay. And this would be negative 4 minus 24 minus 28. I would recommend when doing matrix row operations, you breathe and take your time. Super easy to make a mental math mistake, and you will experience matrix frustration. Matrix frustration happens when you make a small mental math mistake, have no idea where you made that mental math mistake, but things are not working. Sometimes the best strategy with matrix frustration is to start all over again at the beginning and go slower than you did the first time. If it happens again, start again and go even slower. None of the mental math is hard, but it is super easy to make a small mistake. So I have seen students solve these questions in 2 minutes if they luckily make no mistake, and sometimes take half an hour if they continually make mistakes over and over again. Okay, so this means...
Sorry for the interruption. Would the owner of the gray minivan Toyota with the license plate number KTM 199 please come to the office? That's the minivan with the license plate number KTM 199. Please come to the office.
And so we can divide by 7, and y is equal to 4. Then we can go to our first equation, which was 2x minus 3y, and we now know y is equal to 4 is equal to negative 2. So 2x is equal to, add 12 to that side, 10. X is equal to 5. Just check. Is 10 minus 12 negative 2? Yes. Is 20 plus 4 24? Yes. It works. So kind of nice. I don't know. It's compared to our old methods. I don't know if it's more or less work, but it's similar. But when we get to a 3 by 3, which we're not for a while, maybe I'll make up a 3 by 3 for you to do. Question?
Would it still work if instead you made the bottom left 0, if you made the bottom right 0?
It would. It would. However, we're eventually going to get to reduced row echelon form. And reduced row echelon form, like, tell me how hard this is to solve. What do you think x is? What do you think y is? X is 3. And y is 2. This would be like the so Gaussian elimination just got the 0 here and said, well, now we can easily find it. Gaussian Jordan said, well, why don't we make this 0, the diagonal is 1, and this 0. Then it's really easy to see what our final answer is. We don't have to do any math after the fact. And because they have the 0s here and the 1s on this diagonal, kind of like the identity matrix, then yes, it would work to make work to make any of the corners 0, but we're going to develop a system that gets us to the Gaussian Jordan. Okay, I would like you to do the next 2 on your own, and then I'm going to make up a 3 by 3 one for us to do. Yeah, I've got it ready to go. check how you did. First of all, you had to rearrange, right? To get your coefficients and your answers set up. We want to get that one to a 0. So you could do row 1 plus 3 row 2s. Or you could have written it in a different order, that doesn't matter, but that does get me a 0 there, which tells me that 4y is negative 20, and y is negative 5, and then you plug that in, and you get x is negative 1. And then the second one, set things up. This one already. You could have the y's first. It wouldn't have been wrong to write your mate, like, I like having my x's first. But if you had your y's first, you just have to remember that. But you can't have your y's first in one and x's first in the other one. That is problematic. So I set it up there. I'm just going to add row 1 and row 2 to make a new row 2. Then you get y is 5 and x is 2. Did anybody keep the y's first? Okay, and you got the same answer, right? So you just have to remember, like usually we write x and y and then we're like alphabetically prone. So that's what I did here, just to keep things sort of systematic that way. But it wouldn't matter which variables you put where. It kind of makes sense that it's just holding numbers. As long as you know what number it was holding, you're going to be fine. So now we're going to go to a 3 by 3. And this makes things a little bit more complex. I'm going to set up my augmented matrix. And I'm going to think this is my goal. I want all that bottom corner to be zeros. And it's kind of like a Rubik's Cube in a way, that if you start working towards your goal, but then add up equations, you might undo a goal that you had before. Like you had a 0 in the bottom corner, and things were good, and then you added 2 other equations to get a different 0, and your 0 turned back to not be a 0 anymore. So we're going to think back to, and it's very connected to how you would normally solve a 3 by 3 system of equations. What you did is you chose something to eliminate first. Either the x's or the y's or the z's. The difference in Gaussian elimination, what we are going to do first is get rid of x's in 2 of them. Some other things that are going to help us with setup later on. This isn't a necessary step, but it's sure nice if the simplest number is in your row 1. Like of these numbers, the 1 is the simplest. So I'm just going to switch row 1 and row 2. I like having a 1 already in my top left-hand corner. And with the 2 by 2, you only needed 1 0. So your first step was pretty obvious. Now we need 3 zeros, and we are going to do these 2 zeros first, and that 0 second. If you try to do it in a different order, your zeros will just start disappearing because, oh, I got a 0, and then I tried to get another 0, and my other 0 went away. So I tried to get it back, and then my other zeros went away, and you just sort of get in a loop of not getting anywhere. So there is a system to this, and we do want to get those 2 zeros first. And the reason I circled them both at the same time is because we can actually write that we're going to change more than one row here at a time. I want to get this a 0, and I want to get this a 0. So in row 2, I could just take row 2 and minus 3 row 1s. Or I could take 3 row 1s and minus row 2, whichever way you want to write it. And I can take row 3 and minus 5 row 1s. And that will get both of those to be zeros. Does that make sense? I'm changing row 2 and I'm changing row 3. Yes, question.
What is that double arrow?
Switch.
Oh.
Like I'm interchanging them. So row 1 is going to become row 2, row 2 is going to become row 1. So if I do that, I get my first goal. Now, to get my second goal, I'm going to circle this -6 in purple. You're going to have to change row 3, right? Can you see why it would be bad if you used row 1? Like, I can make this a 0 by adding 6 row 1s, right? I can make that a 0. But what's going to happen to my first 0 if I use row 1 again? It's going to change not to be a 0 anymore, and I'm going to be like, oh. Does it make sense that if I want to get this a 0 and I want to keep these two zeros the same, I have to use row 2. So my next one I'm going to say, well, I'll take row 3, and I'll take row 3 and subtract 6 row 2s. That'll get a 0 there. Row 1 and row 2 are not going to change then. And sometimes we get big numbers. I'm like, oh my goodness, 38 equals 190. 38 z's have to equal 190. But when I actually solve for it, it's not too bad. Z is equal to 5. And once I have z is equal to 5, I can go up to row 2 and I can say, I now know that negative y minus 7 times 5 has to equal negative 32. Negative y, add 35 to both sides. And I get y is equal to negative 3. And once I've got z and I've got y, I know that x plus y plus z has to equal 4. So x is 2. And I can write my solution as a coordinate point in 3 dimensions if you wanted. 2, negative 3, 5, or you could just circle x is 2, y is negative 3, and z is 5. So I have a 3 by 3 for you to try on your own. Here's some stuff back. That's what happens when everybody goes electric.
Yeah.
What was the score?
10-1. Lost 10-1 to a TVP 3-2.
So you were missing some significant things.
Yes.
All right, I'll show you the answer for this one. It's -1, -2, 3. If you got that, things were looking good for you. If you did not, start again and try again. Again, you want to get in the matrices these two zeros first, then this one to a 0. I switched rows right away when I wrote them. Without even have to, like, I just decided to write this one first. You might not have. Yours could look totally different than mine. That's perfectly fine. But you should get -1, -2, and 3 no matter which way you decided to write them and how that worked.